Yeah. So let me do the slideshow. Okay. Kalau siapa nak tahu, saya ni office saya ni dalam makmal avionics, ya, di bangunan P20, ya. So siapa-siapa nak datang ke makmal lah. Office saya dekat bangunan pejabat sana. Saya tak suka duduk sebab pejabat. Saya suka dalam makmal. Jadi saya orang makmal. Saya selalu ada dalam makmal lah. Ya. So ini, kita ada WhatsApp group. Saya semua sudah join, ya. Dan saya fikir masing-masing telah ambil electronics dan minimumnya D-, ya. Penting ni sebab most of the things yang kita akan buat dia lebih kepada penggunaan electronics, ya. Application of electronics. So makmal saya ni adalah office saya adalah makmal avionics bangunan P20, ya. Siapa nak datang anytime daripada pukul 8 hingga pukul 5 saya ada di office, insya-Allah. Ya. And then ini adalah kita punya course learning outcome. Awak boleh dapat ni dalam handbook faculty atau school, ya. So ini okeylah. Nah, ini macam mana kita orang akan access awak nilai awak, ya. Pertama sekali kita ada test 1. Dia 25%. Ya. Yang kedua adalah test 2, 25%. Akan diberi tarikh-tarikhnya nanti. Dibuat melalui Google Form dan sebagainya. Ini akan diselaraskan oleh penyelaras. Iaitu Dr. Syahril. Ya. Dan kita ada projek. Okey. Projek ni saya berbeza pandangan sikit dengan lecturer lain. Ada lecturer yang buat dia sebagai satu individu projek. Tapi bagi saya lebih suka tengok awak bekerja dalam berkumpulan. Jadi kerana itu, I would like this project to be a group project. And in the presentation, everybody must present it. Ya. Tentang the topic, pensyarah dalam kursus ni masih lagi berbincang. Ya, sudah ada tajuk tentang lebih kurangnya adalah tentang apa ni? Kena projek nak buat light sensor. Ya. So projek ni masih lagi dibincangkan, apa yang diperlukan oleh pelajar, apa yang pelajar kena buat dan sebagainya masih dibincangkan. Okey. Dan kita ada assignment. Assignment ni individual assignment yang diberi oleh setiap pensyarah kepada pelajar dia. Jadi pensyarah lain akan beri assignment lain kepada grup dia. So awak nanti akan dapat assignment daripada saya yang memang saya sendiri. Ya, awak tak ada chip in daripada pensyarah lain. So itu dia, dan totalnya 100%. Ya. Tahun lepas kita dapati student skor dalam projek dan assignment. Ya. Tapi dalam test 1 dan 2 ni didapati pelajar agak merosot sikit. Ya. Jadi saya harap kita boleh reverse tu, biarlah dapat skor kedua-dua bahagian ni, ya. Okey. Itu assignment. Dari segi buku teks, berbagai lah, ya. Kepada saya, awak boleh, ini satu daripada contoh, ya, yang boleh awak cari, dan juga mana-mana tentang instrumentation technology is good to read. Ya, okay. Now, ada question so far? Okey
Ada
lah.
lagi, Prof.
Tak ada lagi, semua faham. Dan saya punya words semua ni okey, ya. Boleh faham, boleh dengar dan boleh memahami lah, ya. Jangan pula ada yang tak dengar
Boleh.
terlalu cepat, tak ada, ya. Dia
Boleh,
sudah
boleh.
ada. Boleh semua. Okey. Saya kena beritahulah bahawa pembelajaran melalui online ni memang saya punya choice, bukan choice saya lah. Kita terpaksa, ya. Dan saya suka face to face sebab elektronik ni senang dibuat dengan keadaan individual coaching. Mana kita coach student kita secara individu, ya, supaya lebih senang. Kalau awak tengok di belakang saya ni, itu adalah elektronik. Saya duduk dalam makmal yang memang dalam elektronik. Saya harap student dapat datang ke bilik saya ni untuk kalau ada apa-apa masalah dalam elektronik. Ya, boleh guna pun kalau nak. Ya. Anyhow, kalau tak ada question, kita teruskan. So, lecture pertama tentang introduction lah. To measurement and instrumentation. Saya rasa ini adalah lebih kepada revision yang telah awak belajar dalam tahun 1 itu Introduction to Mechanical Engineering dan sebagainya, ya, dan juga dalam electronics. It's more or less is a revision. So sit back and relax lah, ya. Tak perlu nak susah-susah sangat. Kan kalau ada nak tak faham boleh tanyalah, ya. Tentang measurement, kita tahu definition dia adalah satu proses having the object of determining the value of quantity. Ini kita nak tentukan kuantiti sesuatu objek tu, ya. So example quantity yang kita nak ukur biasanya paling biasa kita ukur adalah panjang lah, length, ya. Nombor 2-nya adalah berat. Jarang berat. Ya, banyakkannya dalam kehidupan kita, kalau awak tengok berapa panjang, berapa luas, semua berkaitan dengan length, ya. Dan masa, ya. Pukul berapa ni nanti nak buat. So itu dua. Length and time normally the biggest or the most orang kata quantity yang kita ask, ya. Mass tu jarang-jarang ada, tetapi jarang, cuma masa kita membeli banyakkannya dalam mass, ya, ataupun volume, ya. Dan electrical sekarang ni contohlah. Dan dari segi kita, kerana kuantiti-kuantiti ni pada orang yang lain mungkin berbeza-beza, maka kita nakkan standard. We need a standard, dan kita telah belajar ni dah tahun 1 dulu. Ambil contoh untuk length, kita dapati ada yang guna feet, ada yang guna sentimeter, meter, inch dan apa sajalah, ya. Kalau awak kalau kita tengok orang tua-tua kita dulu, ada yang pakai hun, 1/8 inci, ya. Ada, ya. Kalau dulu, kalau awak dalam marine, ya, zaman dulu, berkaitan dengan length tetapi kelajuan knots, ya. Kita guna knots, ya. Asalnya berapa knots tu adalah simpulan pada tali, ya. Yang mana tali tu diikat dengan satu drag timber, macam timber lah kat belakang, dan kita lepaskan dan kita tengok berapa banyak knot, berapa knot simpulan tali ni dalam masa 1 ataupun 2 minit, ya. So dari situ dipanggil knots, ya, asalnya, tapi itu zaman dululah. Why we need them? Yeah, measurement system are composed of different element and condition, therefore it needs some norms and standard, ya. Kalau kita tengok British punya sistem, kita guna feet, pound and second. Dan kita ada CGS system atau metric absolute system, centimeter, gram dan second, dan international system which use meter, kilogram, second, ya. Asalnya daripada nombor 2, tetapi it's more convenient use meter, and for gram is too small for gram, so we go for kilogram, dan second is still second. So this international is being used all over the world lah. Yang lain tu ada juga, kalau buku-buku lama, ya, 1970s ke belakang, mungkin ada yang menggunakan feet, pound dan second, ya. Ada yang guna sentimeter, gram dan second. Itu bergantung kepada buku-buku lama yang mostly sekarang ni semuanya meter, kilogram, second lah. Ya. Dan kalau zaman saya budak-budak dulu, kita ada timbangan yang kati, cupak dan sebagainya. Yang awak tak pernah dengar pun kadang-kadang tu. Zaman sekarang saya tak tahulah. Ya. Satu kati awak tak pernah nampak macam mana ya. Zaman saya sempatlah. Ya. Dan international standard ni, which is the base unit sekarang ni, dan the system is an international acceptance for measurement. It's founded on 7 SI base unit for 7 base quantity assumed to be mutually independent as the table given. So makna it means that length ni tak ada kena-mengena dengan mass. Tak ada kena-mengena dengan all this. Dia sendiri. Itu adalah unit asas. Ya, kalau kita kata isi padu or volume, volume still has the base unit of length. Ya. So ini adalah independent unit yang ada. Ya, length, mass, time, electrical current, thermodynamic temperature, luminous intensity, candela, and then amounts of substance in mole. Ya. So ini ada 7. And the drive unit based on 7 quantities like area. Yeah, area is just length square, meter square, and we have volume, velocity. All these are derivative from the base 7 base unit. Yeah. So ini semua saya rasa hanyalah revision lah tak? Sama-sama kita buat revision ya. So what is instrumentation? Is a tool or system that is used to measure the quantity of object. Why we need instrument? Ada banyak falsafah di sini, tapi yang saya biasa guna adalah satu adalah kerana kita nak tukarkan sesuatu kuantiti macam sejuk ataupun temperature lah, seperti contoh sejuk dan sebagainya, kepada satu kuantiti yang boleh kita pakai, yang kita standardize. Seperti contoh, kalau kita nak goreng pisang, tak? Kalau awak ni pernah goreng pisang lah, saya tak tahulah yang lelaki ni pernah goreng pisang, tapi saya suka goreng pisang. Ya, kita tengok, kalau nak standardize suhunya, bagaimana? Kita perlukan alat. Ya, sebenarnya kalau dulu orang tua-tua kita dia letakkan sedikit tepung tu ke dalam minyak cukup panas atau tidak. Bila masuk je macam tu dan dia kata cukup panas. Ya, itu satu ketentuan. Tetapi ini tak akan ini akan berbeza dari satu pembuat tepung kepada pembuat tepung yang lain. Tak? Jadi kita dapati itu sebab kadang-kadang kau guna teknik tu, kita dapati goreng pisang kedai ni lebih sedap daripada kedai ni. Selain daripada tepungnya. Ya? So kita nak standardize. So kita nak instrument. So jadi kalau kita nakkan standardize, sebagai contoh, siapa yang pernah bekerja dengan Kentucky Fried Chicken? Ada yang pernah bekerja tak? KFC. Awak pernah tengok tak berapa suhu ayam ketika dia masak ayam tu? Ke tak ada ni semuanya orang kaya tak pernah kerja ni apa?
Tak pernah kerja KFC tu.
Pernah Habis tu tak pernah tengok berapa suhu dia? Dalam masa
tak pernah,
dia
kerja lain pernah.
Dalam dia goreng dalam dia punya pressure vessel tu. Suhu dia kalau saya ingatlah sebab saya pernah kerja daripada dululah. Jadi dulu saya ingat, saya rasa tak berubah suhu dia, ialah 180. Ya? Cuma saya tak ingat berapa dia punya pressure. Dia kekalkan pressure tu supaya Kentucky Fried Chicken di Saudi Arabia yang pernah saya makan, ataupun yang di Australia yang saya pernah makan, ataupun di Malaysia yang menggunakan original recipe, rasa dia sama saja. Ya, crunchiness, juicy inside, yeah, crunchy outside. So all this need something yang secara masakan yang standardized. Untuk standardize, we need some tools so that at least, the very least, the oil that we cook are at the same temperature. Whether you are in Saudi Arabia or whether you are in Malaysia or you are in Australia, it will be the same. Yeah. So we need that instrument supaya boleh memberi kita quantity. Put a quantity to the physical quantity yang nak kita measure. Seperti temperature, berapa degree dan sebagainya. Yang kedua, kadang-kadang kita perlukan instrumen. Why? Kerana kita nak dapatkan quantity objek yang kita nak measure tu sukar. Kadang-kadang kalau kita masuk dalam say furnace, relau. Furnace very hot. Kalau kita pergi ke antara steel di pasir gudang, then dia punya furnace goes up to 1500. Boleh ke kita nak pergi dengan tangan? Rasa ni cukup panas. Tak boleh. We need instrument. Yang ketiga, kita need instrument so that kita boleh tukar kuantiti tu kepada kuantiti yang boleh kita buat sesuatu analisa. Kita engineer. We are engineer. So we need something that kita boleh buat analisa. So kalau kita measure suhu, kita nakkan dia dalam bentuk voltage sometimes. So that kita boleh masukkan dia tu, convert dia ke dalam digital dan masukkan dalam komputer supaya kita boleh buat analisa dan sebagainya. Kita boleh kata, okay, we check this, is still good. This instrument is still okay or fine, whatever. So that we can make analysis and say, put our decision on that. So that is the three main reason why we need the instrumentation. It's not discussed in this slide, tetapi that is what I been told with my lecturer sebelum ni. So I just give you je lah. Sebab slide ni disediakan oleh Dr. Syahril dan saya tak nak ubah sangat lah. So di sini dia kata instrument is a tool or system or that is used to measure the quantities of the object. Example, rulers, measuring tape, multimeter, pressure, all those things, and blood pressure. Okay. So kita pun sekarang ni kita canggih, saya rasa kita punya handphone pun sangat canggih sekarang ni, ada instrumen dalam kita punya handphone. In fact yang sebenarnya handphone kita ni, kalau tengok betul-betul lah, kalau fikir orang hantar manusia ke bulan, ya, they send people to moons, Apollo 11, Apollo 12, ya, to the moon. Their computer is much less powerful than our handphone. Yeah? Remember that. You have more powerful computer in your hand compared to the NASA during they send people to the moon. And that means that if you cannot do anything, it means that it's you at fault, not your equipment. Yeah? So ingat tu, kita punya handphone ni sangat-sangat canggih sekarang ni. Kalau kita tengok minimum sekarang ni, everybody ada dalam 64 gig RAM. NASA dulu hanya ada megabyte. Mega bukannya gigabyte, megabyte. And yet, dia orang boleh hantar orang ke bulan. Control all the atmosphere in the spacecraft, the direction, everything. Yeah. So remember that you have what you have in your hand is a very powerful instrument. And the car, okay, there's a lot of sensor in the car. Yeah. And typical instrumentation system, kita ada transducer. We have transducer, and from the transducer, we have to go through what we call signal conditioning. and then we go to AD converter and then to display. The transducer, yeah, converts the measured value into another useful value. Sometimes transducer dia apa yang kena kat sini say pressure. So we cannot measure the pressure as directly, but we have the transducer to feel the pressure and convert it into other useful values like voltage or current or change in resistance. So we change that, then signal conditioner is convert the signal from the transducer to a form suitable for interfacing with other component. Then since zaman kita ni semua pakai komputer, it must be in digital. So we need analog to digital converter. Yeah, this is what we have. Then after that, of course, we need the presentation, then the display. So for example, thermocouple, thermocouple input dia is the temperature. We don't measure the temperature, we don't feel the temperature directly, but what we measure is actually the output of the thermocouple in EMF, electromotive of in voltage. Then we also have resistive temperature detector, which is the input is temperature, then this convert into resistance. Yeah. So normally all these things, the transducer ni biasanya dia ada hubungan, dia ada relationship that relate between physical quantity with electrical quantities. Like this one, thermocouple, it relates with temperature and voltage. With the RTD, we have temperature. There's an equation that relates temperature to the resistance or the electrical quantities. And we have amplifier, this signal conditioner, yeah, of course. And we have a relation between a small voltage to larger voltage, and these are signal normally in signal conditioner, the input and the output having the same voltage, same type of output. Say like voltage and voltage, only a very rare occasion like Wisdom where we have resistance, then the output is voltage. This quite rare, only one or two example. Most of the signal conditioner normally the input and the output having the same characteristic, yeah, voltage and voltage. Only here is where we have a change in resistance and change in voltage. And display, of course, simple pointer and computer. Okay, so let's think a while. Suppose we have this bolt-on gauge, yeah? Then if we look inside and try to identify which is transducer, which is signal conditioner, and which the display. So if we think carefully, then we look carefully, yeah, we can see that the bolt-on tube here and the linkage here is actually the transducer. Yeah? It's related to pressure and the sort of rotation of this that provided by this tube. Then the gear is actually signal conditioner and that transform the output from the Bourdon tube into a rotation of the gear, and then the display is the pointer or the scale here. So these are what we have. Yeah. Oh, by the way, all this has I have upload all this in e-learning, so don't worry if you sort of cannot take notes, you can have this in the e-learning. Yeah, it's already been upload. So important of instrument and and instrumentation, measurement and instrumentation. In industry application, it's important for monitoring and control of a process, improving the quality of the products and efficiency of the production, and also for the safety purpose. Yeah. And in industry application, it's important for monitoring and control of the process using pressure sensor or temperature sensor. The pressure or the temperature of any manufacturing process will be monitored and used to control the process. Yeah. And improving the quality also is part of the application. The QC engineer, by using laser sensor to measure the diameter of end product, and the quality and the efficiency of the production can be improved. Yeah. And safety purposes, also you have sensor to sensor, probably alarm to set off alarm for something that is dangerous. Yeah. If you are engineer building a ship, normally you put sensor in the engine room in case there is a smoke or fire in the engine room. Then you need to alert the people inside that, so that they can take the proper actions. Yeah, like this. This is monitoring. Yeah, and this is the how to improve the quality. Yeah. And this for the safety purposes. You try to detect if your equipment using ammonia, natural gas, or if there's any leak, the sensor here will try to detect and then set an alarm. Yeah, if there is if the condition is at a dangerous level. So in terms of career-wise, yeah, instrumentation is quite a lot in automobile, in biomedical, but in your case, probably you are designing ship. I don't know what you are your aims, but for the marine, yeah. So there's a lot of sensors. This day, the ship part of the budget to build a ship actually goes to sensors and instrumentation. Yeah, the engine, how big is not as much, difficult than the sensor these days. Not as expensive as the sensor. Yeah, and even more so if you are designing a better ship or cruiser, and you will know that there's a lot of sensor or heavy electronics warfare must be there. Yeah. So this reading exercise you want about the definition of instruments and instrument measurement, and define quantity to be measured by instrumentation system, other application of instrumentation system, level, like level monitoring system, all this explain is, and then you, this for your own to read lah. Yeah. Okay, that is our first lecture today. Now I would like to go to a few things about the schedule, or the how we conduct this subject, yeah, this course. Let me see. And now, for you to do, before this, we used to have a sort of hands-on, sort of session where you have 3 hours in the lab, yeah, and we do hands-on, and I'll show you how to conduct some simple project before you do your own project, so that you get familiarized with the components, all those things. Yeah, but now we cannot do that. University insists that we go for online mode. Yeah, so I would like to bring up something to you that for you to learn yourself and to get familiarized with the circuit. First of all, I would like you to learn what we call Tinkercad. This circuit building CAD, for you, you have to learn it yourself. Yeah, I will show you a few. First, you go to the Tinkercad.com here. Yeah, and then register, login, and then after that you can start building your circuit and learn about a few things. Yeah, I give you one example. Suppose you go in the circuit and create a new circuit. Yeah, if you click here, new circuit. So let me wait for me. So if you go to the Tinkercad, yeah, www.tinkercad.com, then after that you start to register, then you start as what I have done. Then you have this sort of layout where you can actually start to build your circuit, to familiarize with your circuit so that you can do your project later on. Yeah. Okay. So over here, these are the space that you can use to do um, your circuit. So over here, there's a lot of components that you can choose. Yeah, from basic to a few others like Arduino, micro bits, and circuit assemblies, and all you want to list here. So right now I list the basic circuit. You have resistor, LED, push button, everything, and more or less it's more like uh, a component that you will see in the uh, lab. Yeah. So to do your project, yeah, you need to use the breadboard. Something look like this. Oh, mana pula ni? Yeah. So these are the breadboard. Yeah. So you can name it. You boleh klik kat sini and drag ke sini. Yeah. So you need to learn all yourself. Then the breadboard it shows how the connection is. The first row here, all these first row are interconnected. The line here, yeah, all this one line is, they are all interconnected. And the second row here, they are interconnected like this. And the breadboard show the green. In my case, it's the green. Yeah. All the point, all the holes there connected. And if you go in the middle, now the line is connected in this way. Yeah. See, you can see that there is all zero, all the green means that they are interconnected. So if you want to say build something, yeah, then you can first you need the power supply. Say, let me say I take the 9-volt battery and I drag it here, yeah, and put it there, and then if I want to rotate, I have this rotation, yeah. So I can rotate there, and there you are. So the red one is the positive, this is negative. Yeah. So suppose I put a line, I choose the line wire like here, then I draw it there. Yeah. So if I don't like the color, I just put the red color there. Yeah. And if I want to take the negative one, bring there, and then bring over here, click somewhere there, and click there. Then I have connection there. So I don't like the color red, I can change it to black. So now this line, all this line is 0 and this is 9 volt. So now I can use LED, say LED, yeah. If you can see here, the one that is not bent here, this is negative, this is positive, yeah. So I can bring it there, put it there. Okay. And I need a resistor. Say suppose like this. Then I rotate it. Okay, like that. Yeah. And this terminal to say positive terminal. Yeah. Can do it that. And I can have this connect to that. And I can have the negative one over there. Measure that. We have that. So I can change this color to red. This also. So, yeah. Okay. So I have this. So if I simulate that, it's supposed to give something. Probably I made a mistake. Oh, sorry. So simulation. I want to. Okay. So if I simulate, it's supposed to write leak on, yeah, it become red now. If I stop simulation, it become off. So this is how we do the experiment in here. So I want you to learn Tinkercad, yeah, and build some sort of example uh, sort of circuit with that, familiarize with this, because when I give you the assignment, yeah, you have to do that assignment on Tinkercad. So that assignment will ask you to build a circuit on the Tinkercad and provide the solution by print screen the Tinkercad circuit, and also during its simulation, and get the voltage. So please learn about the Tinkercad. Yeah. Okay. Now, let me see. I think that's about all for today about the Tinkercad. So, okay. Now, next is I want uh, to say something about basic components that you're going to use. All this actually is supposed to be in the lab, but I will give you here. Yeah, these are the basic component that you need to learn. Let me see. So this is an introduction to electronic component that you will need to build. It says here motor, speed controller. This previous sort of um, um, previous um, project. Yeah. So anyhow, to do the next project, we still in discussion. You need the same, almost same basic electronic components. First, you need the resistor. How you um, measure, sort of identify this resistor. So resistor looks like this, and this the color that you need to know. Yeah. and this how we actually read the resistor. The first band and second band is just the number, and the third band is actually the multiplier, zero multiplier. Yeah, and fourth band is the tolerance. Yeah, so you have this. If there is 111, it means that this is 110. Yeah, this is 10. 4 is 4 zeros. Yeah, so we have 10 times 10 to the power 4, or 100,000 K. Yeah, so this is how we read the code on the um, uh, resistor. So the band, the fourth band is actually the tolerance, where the gold color is 5%. If you have silver, if I'm not mistaken, silver is 10%. Yeah. And units, so knowing your unit is important. Kilo and mega are common in resistor. Milli, micro, nano, and pico can be used in other component. Normally, milli and micro, normally in inductors, and in capacitor, micro, nano, and pico. Yeah. So what is the kilo? Kilo is 1,000. Mega is 1,000,000. Milli is 1 over a million. Micro is 1 over 1,000. And micro is 1 over a million. Nano is 1 over a trillion. And pico is 1 over, or you call 1 quadrillion. Something like that. Okay. So capacitor, you have that. Yeah, a capacitor store energy. Yeah, looks like this. Yeah, and the unit is being written on the surface of the capacitor. Here, like here is about two uh 2,200 micro, and this is some pico. This is 22 micro. Yeah, polarity of capacitor is the shorter terminal goes to the negative, the longer is to positive. Yeah, so this how physically. And application of capacitor. Capacitor is can supply pool of electrons. It's just a charger, a charging unit ya sebenarnya. And we have diode. Yeah. The diode is one-way valve, or for electric electricity, is a component with a asymmetrical transfer characteristic. A diode has a low, ideally zero resistance in one direction, and high or infinite resistance in the other direction. So the symbol is like this, and this is how we look as it is in the real diode. Yeah. So these are the symbol, and the positive and negative is, if you put positive there and negative there, then the resistance across the current will go through across this without any resistance. If you put this negative, this positive, it become a reverse polarity, and we find that the diode has a very high resistance, or ideally infinite. So if this positive, this negative, it become reverse. Yeah. So this is how the diode being um, connected. Positive, negative, for the current to go through. If this become negative, this become positive, or you can say that if this voltage is less than this one, then it become a reverse polar, and current cannot flow. Yeah. So this how is the bar here is being represented by this band on the diode. Yeah. And for the light emitting, okay, the positive is the longer one. Yeah. And shorter one is negative. Normally in the negative, you have something like this. It has a straight line like this. So this is the negative. This is positive. Or if you look inside it, you find that the positive have a shorter sort of iron something terminal, and this longer terminal inside there. Yeah? So this is how to identify the polarity of LED. So if this sometimes it's not just the straight, but it have a curve like this. Yeah. So we also have a variable resistor or potentiometer. Looks like this. Yeah, is from that terminal to that terminal is a one resistor, and we have a swipe in the middle that going to put this one somewhere in between that resistor. Yeah. So this is how it goes. So there's a wiper there, and these are terminal, and they have three terminals. I think this is all revision of your electronics. Yeah. So we have transistor, looks like this, some like this, some like this. And the transistor is a semiconductor device used to amplify or switch electronic signal and electrical power. Yeah. So you have several type of transistor. You have NPN and PNP. The symbol is like this. Yeah. And you have base. Base actually being used as a either amplifier input or as a switch input, and the output is from collector to emitter. Yeah. So these are the terminology. BJT is bipolar junction transistor, useful as amplifier, collector base emitter, and field effect transistor, useful as a motor driver. Yeah. And so these are the schematic symbols for PNP. Uh, the arrow is inside. So normally the way I understand it, PNP is point in. This pointed in, and for BJT, the NPN is not point in. Yeah, so it's not point. So these are the symbol. This P channel FET, and this N channel FET. So we have also integrated circuit. Yeah, something looks like this, and it's very difficult to see what inside there unless you have the clear circuit diagram of it. Yeah. So there's a billion of type of integrated circuit in the world these days. We are using it, and one of them is probably the Arduino that you have the option to use it in the project. Yeah. What is an IC what an IC can do for us? There's a lot. Yeah, there's a lot. You have to read about this. And op-amp is the most common IC that we use as engineers. So it looks like this, or it looks like in Tinkercad is just dual 8 pin chip. Yeah. So this is the symbol. We're going to go through this again individually later on in our course. Yeah. So this H bridge that we use for motor, because this slide is for motor control. This is why we have a H bridge circuit, but it's not important for you for this. Yeah. Uh, so sometimes we can skip the printer circuit board, but most of the time we use it. Yeah. So I think that's about all for today. Yeah, for today that I want to talk to you. First, on the first introduction lecture, let me stop sharing. First, I talked to you on the first introduction about how we assess you. Yeah, we look at there's 5 elements. We have test 1, test 2. We have project. We have assignment, and Four things that we assess you. Test 1, test 2, and a project. Yeah, and a project is going to be a group project. Yeah, and let you know when I want your the names of the group of your project. I will put it in your WhatsApp later on, yeah, about this project, because right now I cannot say much about the project because the lecturer is still um, uh, discussing on the project. Once it's finalized, I will talk to you and I will make sure I will tell you how many students must be in a group. Yeah. Normally, what I did is 4 maximum and 3 minimum. Yeah. And then there will be a project presentation where everybody has to do the presentation. Yeah. It also depends on how it went, how it goes. If not, we just have the video presentation only, where you make your own video in your project, then after that you just send it to me with a report and also that video. Then no presentation on sort of live presentation. Yeah. So with that, thank you very much. Is there any question to ask? Everybody in UTM right now or still at home? How many in UTM?
3 people, like 3 or 4 people.
Only 3 or 4 people. Okay, thank you very much. Thank you. Only 3. And the rest at home.
Yes, still at home.
Okay. It's okay then. It's okay then. With that, I would say thank you very much. And we meet again next week. And next week, the morning session start at 8:30. Yeah, because I know students when they are at home, they a little bit difficult to wake up early. I don't know. Lepas sembahyang subuh, you still tidur balik. Aduh. Okay. Okay. So with that, thank you very much. We meet again, yeah? Any comment or anything that you say you want to ask or whatever, go to the WhatsApp group and just shoot, yeah? I will glad to answer you to your question. Okay, thank you very much. I will end this meeting for all. Okay, thank you very much. Assalamualaikum.
Welcome, Prof.
Uh,